I am waiting for its starting. Okay. So first of all, good afternoon to all of you, and I would like to thank all the candidates who have joined here in this lecture. Today I am going to discuss how can we make innumerable eutectic liquids by the application of mixed solvency concept. As you know, the first parameter of mixed solvency concept says that each and everything present on the earth has got solubilizing power. So all the solids also possess solubilizing power. Okay, and what happens in the making of this eutectic liquid? Uh, what happens? You see, when you take two solid substances, for example, menthol and camphor. Menthol has got melting point of 44 degrees centigrade. Camphor has got melting point of 179 degrees centigrade. Okay. Now, suppose you dissolve, you take 10 gram of menthol. You heat it to melt at 44 degrees centigrade. You will have clear, colorless, melted menthol. In this, if you dissolve 1 gram of camphor, this camphor gets dissolved in melted menthol because of its solvent character, and you are having a solution of camphor in melted menthol. So what happens here? There is lowering of melting point of menthol. For example, we know in water, if we dissolve the electrolytes, salts, then there is reduction in the melting point of water. Okay, but melting point is not lowered by insoluble substances like calcium carbonate, magnesium carbonate cannot lower the melting point of water. Okay, so in the on the same principle, if you are dissolving 1 gram camphor in 10 gram melted menthol, you are getting a solution of camphor in this melted menthol. And this thiamol acts as impurity to lower the melting point of melting this menthol. And now maybe I have not measured after dissolving 1 gram in 10 gram of melted menthol, 1 gram of camphor. No, I have not checked. But what I want to tell you, suppose the melting point goes lowered, gets lowered around 44 degrees centigrade of of the menthol. Suppose the melting point goes, say, for example, 38 degrees centigrade. Again, if you are adding 1 more gram of camphor, again, maybe now after 38, it is going to suppose 33, like this. So, okay, when you dissolve 5 gram thiamol, or suppose you take 8 gram of this camphor in 10 gram melted menthol, now the melting point is so much decreased that it goes, means the melting point of this resultant solution goes well below room temperature, means well below 25 degrees centigrade, and we get a eutectic liquid. So eutectic liquid involves the theory of solid as solvent. They dissolve because of the dissolution. Okay. Now in other case, for example, suppose you are taking 10 gram of menthol, you are heating it at 44 degrees centigrade, you will have clear, colorless, melted menthol. Okay. Now if you add 1 gram of sucrose in this, it will not be dissolved by this, and there will be no lowering of melting point. Otherwise, it is also impurity for menthol, but since it does not dissolve in this, so it cannot lower. So means all the impurities cannot lower the melting point of melted menthol or of menthol. So all substances cannot make eutectic combinations. Anyway, so now I am coming to the details of all this by means of slides. So now I am starting presentation. Okay, so that in less time I can explain most of the things to you. Okay, so sharing the slide. Now, so this is first slide of today's presentation. Eco-friendly lecture series 7. As all of you know that I have made 6 lecture series already, and they will be available on YouTube. Okay. Today's topic is application of mixed solvency concept to make innumerable eutectic liquids. Eutectic liquids may act as solvent in vast field of science. Means these eutectic liquids can be used for extraction, for TLC, for UV spectrophotometric analysis, for synthesis of organic compounds, and so on and so forth. Okay, So it is very important to make a large number of eutectic liquids. Myself, Dr. R.K. Maheshwari, I am professor in the Department of Pharmacy, it's the GS Institute of Pharmacy, GS Institute of Technology and Science, 23 Park Road, Indore, in Madhya Pradesh, India. My WhatsApp number is +91 94066 21907. Okay, so WhatsApp number is there. Those who want to connect with me, they can note this WhatsApp number. Email ID rkmaheshwari@yahoo.co.in. Website is there, www.rkmaheshwari.com. So many matter is there on this website. And some information, since those who will listen my this lecture only, they should be informed that I have made already 6 lecture series. Eco-friendly lecture series 1. Eco-friendly and economic UV spectrophotometric analysis of poorly water soluble drugs by application of hydrotrophy, mixed hydrotrophy, and a mixed solvency concept without the involvement of organic solvent. Lecture series 2, it says that eco-friendly and economic typiometric analysis of poorly water soluble drugs by application of hydrotrophy, mixed hydrotrophy, and mixed solvency concept without the involvement of organic solvent. Eco-friendly lecture series 3. Each and every substance, whether gas, liquid, or solid, present in this universe has got solubilizing power. Mixed solvency concept. This is the first parameter of mixed solvency concept. Now, 4. If you type these words on Google search, you will get my recorded videos in the form of YouTube. Eco-friendly and economic analytical techniques for TLC of compounds by application of hydrotrophy, mixed hydrotrophy, and mixed solvency concept without the involvement of organic solvent. Eco-friendly lecture series 5, eco-friendly and economic analytical techniques for reverse phase HPLC of compounds by application of hydrotrophy, mixed hydrotrophy, and mixed solvency concept without the involvement of organic solvent. And last means 6th number eco-friendly lecture series says take the topic application of mixed solvency concept to formulate dry powder injection for reconstitution of poorly water soluble drugs. Okay, now coming to next slide. Now, how to understand the formation of eutectic liquid now? So, firstly, we should understand how the eutectics are formed. Okay, suppose, for example, we are going to make the eutectic liquid of 2 compounds, thiamol and camphor. Now, here thiamol melting point is 48 degrees centigrade, camphor melting point is 179 degrees centigrade. We will get a eutectic liquid when you use them in 5:2 ratio. Means 5, for example, 5 gram thiamol, 2 gram camphor. Then you get a eutectic liquid. Suppose you take 5 gram thiamol and 0.5 gram camphor, you will not get eutectic liquid. Okay, I will tell you why. Suppose 5 gram thiamol is trichlorated with 2 gram of camphor. With the help of pistol motor, we get a clear colorless eutectic liquid. Okay. Thiamol has melting point of 48 degrees centigrade. Camphor acts as impurity for thiamol and reduces the melting point of thiamol to the extent that the resultant melting point goes well below room temperature, means well below 25 degrees centigrade. Okay, and we get a clear colorless liquid which you call eutectic liquid. This liquid is a solution of camphor in melted thiamol. It is a solution. We can get this eutectic liquid by heating a mixture of 5 gram thiamol and 2 gram camphor in a test tube also. Means what I want to tell you, it is not necessary that you triturate them. What you can do in a test tube, if you take 5 gram thiamol, 2 gram camphor, you heat it. When this thiamol will melt at 48 degrees centigrade, it will dissolve camphor. And now if this liquid is cooled down up to room temperature also, then also it will not solidify. This you will get a clear colorless liquid. Why? The reason is, now let me explain. Eutectic formation is essentially a dissolution process. One of the 2 ingredients has melting point nearer to room temperature. For example, in this case, thiamol has melting point of 48 degrees centigrade. Other ingredient should have quite good solubility in a melt of lower melting point ingredient. For example, in thiamol, means camphor should have solubility in melted thiamol. Has very good solubility in melted. For example, camphor, which has got melting point of 179 degrees centigrade, has very good solubility in melted thiamol, with the melting point is 48 degrees centigrade. In this case, 2 gram camphor dissolves in 5 gram liquefied means melted thymol, and this amount of camphor brings the melting point of thymol well below room temperature. This liquid does not solidify even in freezer compartment of household refrigerator, where we freeze the water for making the ice. Here in this compartment also there is no freezing, means no solidification, only the viscosity is enhanced, is increased. However, the viscosity of this Eutectic liquid is increased at this temperature, just for your information. Okay, now coming to note, suppose we take 5 gram thymol and 2 gram sucrose and triturate with the help of pestle and mortar, or we heat a mixture of 5 gram thymol and 2 gram sucrose using water bath, we do not get a eutectic liquid. Why? Here the impurity of sucrose does not lower the melting point of thymol. Why? What is the reason for this? So we are discussing this. Okay, now because sucrose is nearly insoluble in melted thymol, that's why it does not lower the melting point of thymol. Thus, it is essential that one of the two ingredients should be soluble in melted liquid of other compound of low melting point. Means, for example, here, means sucrose is not soluble, that's why it is not making any eutectic liquid with menthol. Simple method to decide the ratio of two ingredients of a eutectic mixture. Always you will find in your books that in particular ratios, when the two solids are mixed, then you get eutectic liquid. It does not mean that if you mix the two substances in any ratio, you will get eutectic liquid. No. For another example, of course, we are not talking about any formulation. We are just learning the methods of making the eutectic liquid. For example, I have made phenol and caffeine eutectic mixture. How did I make? Take 9 gram phenol in a test tube and add 1 gram caffeine and heat it on water bath at about 50 degrees centigrade. Why 50 degrees? Because the melting point of phenol is 44 degrees centigrade. Okay. Now as soon as phenol is melted, melting point is 44. Shake the test tube for about 15 minutes. What do we want to? We want to dissolve caffeine in the melted phenol. Take help of water bath to maintain phenol in melted condition. 15 minutes shaking will be done during the melted stage of your phenol. Okay, so that it can dissolve this caffeine. As soon as clear solution of caffeine is obtained, okay, allow the solution to cool to room temperature. What you have done, you have dissolved 1 gram of caffeine in 9 gram of melted phenol, and after dissolution, when you get a clear solution, you are putting it, you are keeping it to lower its temperature to reach the temperature of room, means room temperature, to reach room temperature. Okay, at room temperature, we shall not get a colorless liquid. At this time, we will not get colorless liquid, means we will not get eutectic liquid. This I have done, I am telling you. Okay, now add 0.5 gram more of caffeine and repeat the same procedure, means again you heat it to dissolve. Again, we shall not get a clear colorless liquid, means 9 gram of phenol and 1.5 gram of this caffeine does not give eutectic liquid. Again, you will go on adding 0.5 gram of this caffeine each time. Okay, when shall you get this liquid? When 3 gram. We shall get clear colorless liquid when 3 gram of caffeine is heated with 9 gram of this phenol. This means we get a eutectic liquid of phenol and caffeine in following ratio: 9:3. 9 gram phenol, 3 gram caffeine, means 3 gram phenol, 1 gram caffeine. So in this ratio, you will get a clear liquid, means eutectic liquid. Why we have obtained a eutectic liquid? Again, the reason: a large amount of caffeine has been dissolved in melted phenol. This caused the lowering of melting point of phenol to such an extent that resultant melting point of a mixture of phenol and caffeine in 3:1 ratio goes well below the room temperature, and a eutectic liquid is obtained which remains in liquid state at room temperature. So in this way you are getting a eutectic liquid. I am not telling you for making any formulation, but I have shown that phenol has got lower melting point, 44 degrees centigrade, and caffeine is soluble in melted phenol, and in good amount it is soluble. When a large amount has been dissolved in this, then only it reduces its melting point, it lowers its melting point sufficiently so that the resultant melting point goes below room temperature. What does it mean, the resultant melting point? Means, for example, you have dissolved 3 gram of caffeine in 9 gram of phenol. It is a solution. Okay, so you may say this is a separate a mixture of two compounds. The melting point of this blend is quite lower than the melting point than the temperature of room, means room temperature. That's why you are getting a this liquid. This Eutectic liquid does not solidify. Means this one means phenol and caffeine. Okay, in 3:1 ratio. It does not solidify at 2 to 8 degrees centigrade in household refrigerator where we put these vegetables and milk, etc. That is in a cool condition, 2 to 8 degrees centigrade. It does not solidify. Which is in this solution means Eutectic liquid of caffeine with this phenol like this. Okay, but when we keep this liquid in freezer of freezer compartment, then of course it gets. However, this Eutectic liquid gets solidified in freezer compartment of household refrigerator. What do you mean by this? This means the lowering of melting point is up to the level of nearly up to 2 degrees centigrade. You may see. Means at 2 degrees centigrade also you are having a liquid. But if you are further reducing the temperature, means in minus, okay, minus, so then of course it can solidify. Means there is lowering of melting point of this phenol by dissolution of caffeine well below 8 degree, well below 5 degrees centigrade, and so on, so forth, like this. Okay, now coming to, now again I want to tell you that there is no relation with the formulation. This is just example, not to relate with pharmaceutical formulation. Now another example of Eutectic liquid. Now again there is no question of formulation. I want to explain this also. Now phenol and niacinamide in 5:2 ratio, you will get a clear Eutectic liquid. Okay, take 10 gram phenol in a test tube and add 1 gram niacinamide and heat it on water bath at about 50 degrees centigrade. The phenol melting point is 44, so you will get phenol melted. As soon as phenol is melted, shake the test tube for about 15 minutes. Take help of water bath to maintain the phenol in melted condition. Okay, so that you can shake the mixture. Okay, now as soon as a clear solution of niacinamide and melted phenol is obtained, allow the solution to cool to room temperature. How much quantity we took this? Let me see, 10 gram. Okay, and how much we have added? 1 gram. So 1 gram melted phenol has dissolved 1 gram of this. Okay, so this 1 gram by dissolution of 1 gram, the melting point is lowered, but not to such an extent that you get a Eutectic liquid. Okay, now so what do you do? Now at room temperature we shall get a clear. Now add again 0.5 gram more of niacinamide. This total became 1.5 gram of this niacinamide, 10 gram of your phenol. Again you repeat the same procedure. So what you are doing, you are going on adding 0.5 gram of niacinamide. Okay, when you will get, at what stage shall you get Eutectic liquid? When 4 gram of niacinamide, total 4 gram niacinamide gets dissolved in melted 10 gram of phenol, then you will get Eutectic liquid. Means the resultant melting point of this liquid means this, you will say the mixture is lower than the room temperature. Okay, like this. So phenol, niacinamide and ratio of 10:4 means 5:2 means 2.5:1 means 2.5 gram phenol, 1 gram niacinamide. Whether you heat it in test tube, then also you will get Eutectic, or if you try to it with the help of piston motor, then also you will get. Okay, now why we have obtained a Eutectic liquid? This is the question. Why we have obtained a Eutectic liquid? A large amount of niacinamide has been dissolved in melted phenol. This caused the lowering of melting point of phenol to such an extent that the resultant melting point of a mixture of phenol and niacinamide in 5:2 ratio goes well below the room temperature, and we get a clear colorless liquid eutectic. It is obtained. It remains liquid state at room temperature. Note, this is just example, not to relate with pharmaceutical formulations. Okay. In the same way, following eutectic liquids were made by me. Okay. Uh, now, uh, the reason why I have used metformin hydrochloride, why I have used lignofen, it is something which can be discussed later on. But what I have done, that I am telling to you, phenol and metformin hydrochloride also gives you eutectic liquid in the ratio of 4:1. Means if you take 4 gram phenol and 1 gram metformin hydrochloride, whether you triturate or you heat it, you will get a eutectic liquid. Similarly, phenol and lignocaine hydrochloride in 4:1 ratio, again you will get eutectic. The thing is that metformin hydrochloride has got very good solubility in melted phenol. Similarly, lignocaine hydrochloride has got very good solubility in melted phenol. That's why you are getting the eutectic liquid. This is just example, not to relate with formulation. Okay, coming to next slide. Something about the eutectic liquids, the effect of lowering of temperature. So let me show you some for some information point of view. What I have seen, I am informing you that eutectic liquid, this thiamol and camphor in 5:2 ratio, this eutectic liquid do not solidify in freezer, only viscosity is increased. Freezer of the household refrigerator. Now thiamol and menthol in 1:1 ratio, this also does not solidify at this temperature of freezer. Okay. Now phenol and caffeine 3:1 ratio, this eutectic liquid do not solidify at 2 to 8 degrees centigrade, but it solidifies in freezer. Okay. Phenol and PG for 6000, this ratio I do not remember, but I made eutectic of PG 6000 and phenol also, but that ratio I don't remember. I could not write in my copy, so I don't know the ratio. But means you can try phenol, this PG for 6000 phenol, you will get, but the ratio you will have to determine in what ratio this will be mixed, so that you will get eutectic liquid. Phenol, ibuprofen ratio I don't remember, but ibuprofen also makes eutectic with phenol. Of course, we are not talking about the formulation. Just we are discussing how can we make the various types of eutectics, so that the other persons, they can take appropriate solids, and then they can prepare the eutectic liquid for their desired purpose. Okay. Now phenol ibuprofen eutectic, when it was kept at 2 to 8 degrees centigrade, it was solidified. Means its a melting point reduction was not up to 8 degrees centigrade or, and so on and so forth. That's why it was solidified. Okay. Similarly, phenol and vanillin, this eutectic also, and menthol and camphor, this also like this. Okay, now coming to another slide. Now, how to make innumerable eutectic liquids? How to make? Now you will you should learn this art, that how can you make innumerable eutectic liquid. Just for example, we are not making any formulation. This is just example, not to relate with pharmaceutical formulation. Okay, suppose we have to make eutectic liquid using 2 solids. You can make a eutectic liquid of using 3 solids, 4 solids, so on and so forth. But here we are discussing the method for making eutectic using 2 solids. Okay, at least one of the 2 solids should have melting point near to room temperature. That is near to 25 degrees centigrade, that is the room temperature. Means melting point of one of the 2 ingredients should be, say, 40 degree, 50 degree, 45 degree, 60 degree, 55 degree, and so on and so forth. Okay. Now another requirement of to get eutectic, another requirement. One requirement was out of 2 solids, one should be of lower melting point near to room temperature. Another requirement, second solid which you are selecting, second solid should have good solubility in melted liquid of first solid having lower melting point. This thing should be there, then only you can find, and that should be solubility should be also good solubility. Then only you can make it's a eutectic liquid. Okay. I have sorted out now what I have done. From Indian Pharmacopoeia 2007, I searched some of the chemicals which are the reagent which were having means such solids which were having lower melting point. For example, group A, low melting point solids. Now you see it. Number one, triclosan. Okay, its a melting point is 55 degrees centigrade. Benzophenone, melting point 48 degrees centigrade. 2,5-dimethoxybenzaldehyde, melting point 50 degrees centigrade. Diphenylamine, melting point 55 degrees centigrade. Methyl stearate, melting point 38 degrees centigrade. 1-naphthylamine, melting point 51 degrees centigrade. Number 7, 2-nitrobenzaldehyde, melting point 43 degrees centigrade. Benzyl acetone, melting point 41 degrees centigrade. Phthalaldehyde, melting point 55 degrees centigrade. So these all selected solids were having their melting point near to room temperature. Okay. Now, so that is group A. Now in group B, you can take any compound in group B, but of course they should be solid. That is there. Okay, but they should have good solubility. Okay, so that can be checked because you don't know whether salicylic acid is soluble in melted say benzaldehyde, benzyl, whatever these compounds were there. Anyway, so here you see the compound B. This I have made from my own. That salicylic acid can be used, benzoic acid. We have to try. I don't know that they will make or not, but you can do your own trial and you will get success to get so many eutectic liquids. So niacinamide, aspirin, then your ibuprofen, resorcinol, aceclofenac, naproxen, indomethacin, pyroxicam, then your this paracetamol, caffeine, etc. So this is group B. Okay, so we will take one compound from A and one compound from B. Then we'll now note not to relate with we are not going to formulate anything. Suppose we select benzophenone from melting point 48 degrees centigrade from group A. Okay, you have decided this. Now, and caffeine from group B. So two solids you have decided. Now, we have to see whether we will get eutectic liquid or not. Now, can we try eutectic liquid of two solids, benzophenone and caffeine? Okay. Now, take 10 gram benzophenone, which is a solid of melting point 48 degrees centigrade, in a test tube and add 1 gram caffeine. Okay, and heat it on water bath at about 50 degrees centigrade, because 48 degrees is its melting point. So 50 degrees centigrade is sufficient to melt benzophenone. Okay, and what you have added, 1 gram caffeine. Now you shake the test tube. As soon as benzophenone is melted, melting point 48 degrees, shake the test tube for about 15 minutes. You try to dissolve. Take help of water bath to maintain benzophenone in liquid condition, melted condition. To maintain benzophenone in melted condition. As soon as clear solution of caffeine is obtained, suppose we are getting caffeine clear solution. Okay, up to this time, what we have done, you have seen that 1 gram of caffeine can be dissolved by 10 gram of benzophenone. Okay, I think we have taken 10 gram now. Let me check. Yes, 10 gram we have taken. So 1 gram you have you are getting a solution, but we have to check whether by lowering our temperature up to room temperature, does it solidify or not. Suppose it gets solidified, means this cannot give you the eutectic liquid. Okay, so what you will do, you will go on adding 0.5 gram of caffeine, so 1.5 gram. Now again it has made solution. Okay, and then you are if you are not getting any solution at any stage, then you need not to proceed forward. Why? Because since 1 gram cannot be dissolved by 10 gram of benzophenone, this means it does not have good solubility. So you stop your these two compounds here itself. And if you are getting solutions, then you have to proceed 0.5 gram like this. So in this way, when suppose by addition of, say, for example, you see, suppose what they are saying here, we have to proceed, suppose 5 gram caffeine, suppose 5 gram caffeine with 10 gram of benzophenone gives a clear liquid, a clear solution at the time of dissolution, and then after lowering the temperature of this up to room temperature, then also suppose it is liquid. This means in this ratio you can select to make the eutectic liquid of these two compounds like this. So suppose we are getting a eutectic compound, so what will be the ratio? 10 is to 5. 10 is to 5 the ratio. Means 10, yeah, this 10 gram this, 5 gram this. So in 2 is to 1 ratio. So whether you make this Eutectic liquid by heating, or if you triturate, then also you will get, because during trituration what happens, heat is also generated that will melt benzophenone, and once it gets melted, then the caffeine will get dissolved in that, and a time will come when after a sufficient say trituration, you will get a clear colorless liquid, Eutectic liquid you will get. Okay, so in this way you will try. Note, this was for explanation only. I have not worked on this. I have not worked, but just I want to inform you that how can you do. Okay, note one. Suppose we do not get a clear solution of 1 gram of caffeine in 10 gram melted benzophenone. So what you have to do, you have to stop this process. In first step, do not proceed further. Take another solid from group B and proceed in the same way. Means in place of caffeine, you may select salicylic acid, ibuprofen, or any other compound from the group B. And again, you will repeat that in the same way like this. So when you will get a clear colorless liquid at room temperature, means in that particular ratio you can make it a Eutectic liquid. Note 2, we can select 2 solids at the same time from group B. Also, if you want to make with the help of 3 solids this Eutectic, so one will be of lowering melting point, 2 may be of any melting point. They may be. So like this. So suppose, anyway, leave it here. Otherwise, if I will explain, it will take more time here. Now, note 3. Depending on your purpose of Eutectic liquid, you can try solids of your own choice. Now, after learning this art, you said to make the Eutectic liquid, what you can do, depending on your choice, for which purpose you are going to use your Eutectic liquid, you can select your own, you can try your own solids. Okay. Now, number 4, note, thus by permutation and combination, we can have innumerable Eutectic liquids. You can have innumerable. For example, very simple. What you can do, if you take menthol, melting point is 44, thymol, camphor, phenol, 4 things, then also you can get this Eutectic liquid. If you take 5 things, then also you can get this Eutectic liquid. So there are innumerable ways by which you can make these Eutectic liquids. Okay. Now coming to another slide. Now, some of the applications of various Eutectic liquids made with the application of mixed solvency concept. Now, we have to see in the applications of these Eutectic liquids. Number 1, Eutectic liquid can act as solvent to carry out synthesis of organic solvent. Now, as I have explained that solids also possess solubilizing power. So when they make Eutectic liquid, the molecules of these solids come in liquid state, and then they can demonstrate their hydrogen bonding and weak van der Waals forces, and they can dissolve, or they can increase the solubility of substances. So what you can do means, now after getting a Eutectic liquid, now it will behave as solvent. It will be good solvent for some solute and bad solvent for other solute, as you have seen so many times. Okay, Eutectic liquid can act as solvent to carry out TLC of compounds. Okay, TLC of, for example, you see organic solvent, synthesis of organic solvent. How can you imply? Suppose you are making Eutectic using menthol and thymol, for example. If your menthol and thymol are not reactive with your reactants A and B, which are reacting to get compound C. If menthol and this thymol do not react with A, do not react with B, do not react with C, means product, then you can use this also to act as solvent. Only thing is, the A and B should be soluble in this Eutectic liquid. So what you can do, in place of any organic solvent, you can dissolve these 2 reactants A and B in your Eutectic liquid, and then you try some temperature for its reaction to occur. And okay, and after that, when the reaction product C is formed, then you can remove menthol and thymol by heating at about 70 degrees centigrade, 60 degrees centigrade. You can take help of vacuum drying. So in this way, there will be removal of menthol, thymol. Okay, and of course, compound A, B, and C, they should not be volatile. Anyway, so there are so many things. And again, I will make more slides for synthesis and all that also. Anyway, coming to Eutectic liquid can act as solvent to carry out TLC of compound. In Pune, Dr. Deshmukh madam is there. Her team has done work on this TLC of herbal extracts using Eutectic liquid, and she has filed a patent, Indian patent, on this on the use of this Eutectic liquid as solvent to carry out the TLC. Number three, Eutectic liquid can act as solvent to formulate NDDS. For example, what you can make microsphere, you can make solid lipid nanoparticles, liposome, etc. using the solvent power of the Eutectic. Okay, so the detail you will get later on. Coming to number 4, Eutectic liquid can act as solvent to formulate sustained release solid dispersions also. Then number 5, Eutectic liquid can act as solvent to carry out extraction of active constituents from herbal powders, etc. Okay, this I will explain you extraction. Okay, number 6, Eutectic liquid can act as solvent to carry out UV spectrophotometric analysis of poorly water soluble drug to show the PPT. Now I am going to show you a PPT. Okay, now coming to PPT. This one, this I have shown. This one. Now one more thing. Let me finish here. Very briefly, I would like to tell you what I have done using a Eutectic of phenol and niacinamide. I have made a phenol and niacinamide in 2.5:1 ratio. This was used as solvent to carry out the UV spectrophotometric analysis of tinidazole tablet. Okay, tinidazole tablet without the use of any organic solvent. Means briefly, I would like to tell you that this Eutectic liquid of phenol and niacinamide was used to extract out tinidazole from the tinidazole tablet powder, and further dilution was done with water, because phenol and niacinamide, they are water soluble, and then absorbance was noted at 318 nm. Okay, and by using the Calvison curve, using the same Eutectic liquid as solvent, and further dilution with water, your Calvison curve was used to find out the drug content of tablet. Now the reason is phenol and niacinamide, they do not interfere above 292 nm, and that's why you are able to take the absorbance at 318 nm of tinidazole accurately, and so on and so forth. Okay, now coming to another this extraction. Now you can you can take the reference of this extraction of active constituent using solvent action of solid. This is a published paper. You can see on Google search, it is full paper is available. Eco-friendly extraction using solids, a novel application of mid solvency concept, and these are the authors, and this is the full detail of the published paper. So you can refer this paper. Briefly, I will explain you how the work was done. One more thing, the same means this work has been filed for a patent, Indian patent also. Now, briefly, to Eutectic liquid of menthol and thymol, since we are talking about the Eutectic, menthol and thymol, Eutectic liquid 1:1 ratio, it is very good solvent for sesame oil. Sesame oil is found in sesame seed powder. So more than 1 ml of sesame oil is soluble in 1 ml of menthol thymol Eutectic liquid. Means there is very good solubility of sesame oil in this Eutectic liquid. Then this Eutectic liquid was used to extract out that sesame powder from sesame seed powder, and here the yield was found to be 26.6%. of how it was done. Say for example 3 gram of sesame seed powder and 9 ml of this Eutectic liquid of menthol and thymol. It is good solvent for sesame oil. They were shaken for 30 minutes. During this shaking, this Eutectic liquid dissolved sesame oil from the sesame seed powder, staining through muslin cloth. Okay, and then the liquid was kept in oven at about 70 degrees centigrade to remove menthol and thymol. Of course. Okay, when all menthol and thymol they were removed, there was sesame oil was obtained. Now here there is no question of cost. Don't say that menthol is costly. This I am not saying this thing. I am saying just that menthol means just like this. You can make the Eutectic liquid, and firstly you should see whether those solids are removable by heating or not. Of course, so many things are there. I will make one more. lecture series on extraction. So you please wait for that. But briefly, I told you that eutectic liquids can also be employed in extraction also. Okay, now after this, now extraction using a eutectic liquid. Okay, this I have explained. Okay, now, acha, okay. Chaliye, so in this way now the lecture is over. Whatever I wanted to tell you, of course, time is also too much. So I have to stop the presentation now. Firstly, I will have to go to stop the recording. So stop recording.